This lesson is about independent dependent events. Let's get started. Lesson 2.3.3 Independent and Dependent Events. By the end of the period, with at least 80% mastery, students will be able to explain the difference between independent and dependent events, solve real-life problems involving probability of independent and dependent events. Definitions. Independent events or not affecting. Two events A and B are said to be independent events if the occurrence of one event does not affect the occurrence of the other event. For instance, if a coin is tossed twice, the outcome of the first toss, head or tail, has no effect on the outcome of the second toss. Dependent events or affecting. Two events A and B are said to be dependent events if the occurrence of one event does affect the occurrence of the other event. Let's look at some examples. State whether the events are independent or dependent. Rolling a die and getting a 6, and then rolling a second die and getting a 3. So it is independent. The result of rolling one die does not depend on the result of rolling another die. Number 2, drawing a card from a deck and getting a queen, replacing it and drawing a second card and getting a queen. So, since after you draw a card, you replace it, so bring it back to the deck, therefore, the total number of cards did not change. So, this is an example of an independent event. Number 3, drawing a card from a deck, not replacing it, and then drawing a second card. So this time, after you have drawn the first card, you did not put it back to the deck. Therefore, the total number of cards now changes. So this is now an example of a dependent event. Number 4, selecting a ball from a jar, not replacing it, and then selecting a second ball. So it's just similar to example number 3. Therefore, this is an example of a dependent event. Number 5, having high grades and getting a scholarship. Of course, your scholarship will depend on your having high grades. So this is an example of a dependent event. Number 6, parking in a no parking zone and getting a parking ticket. So again, this is an example of a dependent event because you will only get a parking ticket if you park in a no parking zone. Tossing a coin and getting ahead, and then tossing another coin and getting ahead. So there are two different coins here. Therefore, the outcome of one coin will not depend on the outcome of the other coin. So this is an example of an independent event. Multiplication rule number 1. When two events are independent, the probability of both occurring is probability of A and B equals the probability of A times the probability of B. So, in order to find the probability of two independent events that occur in sequence, we must find the probability of each event occurring separately and then multiply the answers. Letter B. Solve the following problem. Show your work. A coin is tossed twice. Find the probability of getting two heads. So, the probability of head and then head, since they are independent, is the product of the probability of getting a head on the first toss and the probability of getting head in the second toss. So probability of getting head in the first toss is 1/2, and the probability of getting a head in the second toss is also 1/2. Therefore, if you multiply these two, you'll get 1/4. Number 9. A coin is flipped and a die is rolled. Find the probability of getting a head on the coin and a 4 on the die. So they are independent events, coin and die. So the probability of getting a head on the coin and a 4 on the die equals the product of the probabilities of the head and the 4 on the die, which is for the coin it is 1/2, and for the die, 4 on the die is 1/6. So multiplying, we get 1/2. Number 10. Card is drawn from a deck and replaced. Then a second card is drawn. Find the probability of getting a queen and then an ace. So, independent events, probability of getting a queen and an ace equals the product of the probability of getting a queen and the probability of getting an ace. Probability of getting a queen, there are 4 queens, so 4/52. And the probability of getting an ace, there are also 4 aces out of 52, so 4/52. So if you multiply this two, you'll get 16/2704. A jar contains 3 red balls, 2 blue balls, and 5 white balls. A ball is selected and its color noted. Then it is replaced. A second ball is selected and its color noted. Find the probability of each of the following. Selecting 2 blue balls. So, selecting 2 blue balls, the probability of ball in the first draw and ball on the second draw is the product of these 2 blue balls, which is, since there are only 2 blue balls, and the total here is 10, so we have 2/10 times 2/10 equals 4/100 or 1/25. Selecting a blue ball and then a white ball. So blue and white, which is probability of getting a blue is 2/10 and probability of getting a white is 5/10. The product therefore is 10/100 or 1/10. Selecting a red ball and then a blue ball. So probability of getting red and blue equals the product of the probabilities of getting red and blue is 3/10 times 2/10, which is equal to 6/100. Multiplication rule. Multiplication rule 1 can be extended to 3 or more independent events by using the formula probability of A and B and C and so on until K equals the product of all these probabilities. A third ball is selected and its color noted. Find the probability of selecting a red ball and then a blue ball and then a white ball. So notice that after you draw any of this ball, it is replaced back to the jar. So this is an example of an independent event. Probability of red and blue and white equals the product of these 3 probabilities. which is 3 over 10 times 2 over 10 times 5 over 10 equals 30 over 1,000 or 3 over 100. So far, we have learned the formula for finding the probability of two events which are independent. And this is called multiplication rule number 1. For dependent events, we use multiplication rule number 2 to find the probability of two events. The probability of A and B equals the probability of A times the probability of B given that A has already occurred. Example, a bag contains 2 yellow, 12 red, and 6 green marbles. Find the following probabilities. Selecting a red marble, replacing it, then selecting another red marble. Since after we selected the first marble, we replaced it back to the bag, then the total number of red and the total number of marbles did not change. Therefore, we use multiplication rule number 1. This is independent events. So we have probability that the first is red and the second is red is the product of the probability of red times the probability of red, which is 12 over 20 times 12 over 20 equals 9 over 25. Letter B. Selecting a red marble, not replacing it, then selecting another red marble. So, after we selected the first red marble, we did not replace it back to the bag. Then after that, we selected another red marble. So this is the case of a dependent variable because the total number of red marbles and the total number of marbles change. So we use formula number 2. We have probability that the first is red and the second is red equals probability that the first marble drawn is red times the probability that the second marble is red given that the first marble is red. So, we substitute the values. We have 12 over 20 times 11 over 19, which is equal to 33 over 95. C. Selecting one yellow marble, not replacing it, then selecting a green marble. So this is just similar to letter B. We have probability that the first is yellow and the second is green is equal to probability that is yellow times the probability that is green after the yellow has occurred. So substituting the values, we have probability that yellow is 2 over 20 times the probability that it is green given that the first was yellow. So 6 over 19. And simplifying, this is equal to 3 over 95. 3 cards are drawn from an ordinary deck and not replaced. Find the probability of the following. A. Getting 3 jacks. Since the cards drawn are not replaced, then this is the case of dependent events. So, the probability that the first is a jack, the second is a jack, and the third is a jack is equal to the probability that the first is a jack times the probability that the second is a jack given that the first is a jack times the probability that the third is a jack given that the first two are jacks. So substituting the values, we have 4 over 52 times 3 over 51 times 2 over 50 equals 24 over 132,600. The probability that the first is an ace and king and queen equals the probability of an ace times the probability of a king given that the first was an ace times the probability of a queen given that the first was an ace and the second was a king. So substituting, we have 4 over 52 times 4 over 51 times 4 over 50 equals 64 over 132,600. Letter C, probability that is a club and spade and heart equals probability that it is a club times the probability that it is a spade given that the first was a club times the probability that it is a heart given that the first two are clubs and spades. So, substituting, we have 13 over 52 times 13 over 51 times 13 over 50 is 2,197 over 132,600. There are 7 girls and 3 boys in a class. 2 students are to be randomly chosen for a special project. What is the probability that both students will be girls? So this is again a case of dependent events. So using multiplication rule number 2, we have the probability that the first is a girl and the second is a girl equals the probability that the first is a girl times the probability that the second is a girl given that the first is a girl equals 7 over 10 times 6 over 9 equals 7 over 15. What is the probability that both students will be boys? So, probability that the first is a boy and second is a boy equals the probability that the first is a boy times the probability that the second is a boy given that the first was a boy equals 3 over 10 times 2 over 9 equals 1 over 15. And C, what is the probability of selecting a boy and a girl? So we have boy and girl equals probability that's a boy times the probability that is a girl given that the first was a boy equals 3 over 10 times 7 over 9 equals 7 over 30. If there are no more questions, then let the students complete the classwork sheet until the end of the period. Have a nice day.